Folks, in this video we are going to be looking at many slit diffraction. And the tool, which has a lot of slits in it to diffract light, is called a diffraction grating. So these are pictures of diffraction gratings on the top here. We have several diffraction gratings in our classroom that looks just like this. The 500 lines per millimeter means that there are 500 slits for each millimeter of this grating overall. So this is the sort of extreme end of diffraction, right? We looked at double slit diffraction patterns first, and then just one single slit, and now the other extreme is lots and lots of slits. Here, 500 lines per millimeter. We see below in this picture the result. We shine a laser, which is the bottom of the image, through this diffraction grating, which is this rectangle, and the light diffracts out. So a diffraction grating is a device with many slits, way more than just two that we saw in the double slit experiment. This equation, m lambda equals d sine theta, still works, so we're still in good shape there. The thing we need to know is how do we figure out the separation distance, d? Diffraction gratings are rated just like the one on the image in the right. They're rated in terms of lines per millimeter. The inverse of that will tell you the millimeters per line, the slit separation distance. So for example, the slit separation distance for the diffraction grating on the right is distance is your spacing per line, which is 1 over your lines per spacing, which is 1 over 500 lines per millimeter, or the distance between each line is 0.002 millimeters. Diffraction gratings are a great way to separate light out by wavelength. And so we can see white light coming into a diffraction grating, and it diffracts out in different colors, diffract different amounts. Here we have the central bright, where we still have white light because all of the different wavelengths are going to meet at the central bright. But then at the m equals 1 order of diffraction, we can see the blue and the yellow and the pink separate out different amounts. And then at the m equals 2, again, the blue, the yellow, and the pink all separate out different amounts. So diffraction gratings are a great way to separate light out by wavelength. They do so using diffraction. We saw prisms did that using refraction earlier, but this uses a different wave property of diffraction. It works better than prisms, it turns out. So getting light to separate out by bending, refraction, isn't as good as curving around a barrier and diffracting. So here's a schematic of that same idea. Here we have purple light, which is a mixture of red and blue light, and it's incident on a diffraction grating. You can see this grating has lots and lots and lots and lots of slits on it. The light then diffracts, and we get different interference patterns. We get still purple light in the middle, m equals 0, but the m equal 1's lines, the first order bright for red is at a different location than the first order spot for blue. The second order spot for blue is at a different location than the second order spot for red, so on and so forth. This envelope is telling you the intensity or the brightness of the light, and we can see that it gets dimmer the further you spread out. Warning, here's a difference between double slit and diffraction gratings. In a double slit, you can usually assume that both the screen is far and the angle is small. So our far screen approximation, m lambda equals d sine theta, that's it good. And then also, for a small angle, this can become wide right is m lambda L over d. That's usually pretty good too. For a diffraction grating, you can still assume that the screen is far, but you definitely cannot assume that the angle is small. So m lambda equals d sine theta, check, nailed it. But sine theta, tangent theta, not the same. So we can't go any further than that. This wide bright equation does not work for diffraction gratings. So instead, you can just figure out theta first, and then use tan theta equals y bright over L to find, to figure out where bright spots are. All right, so that's diffraction gratings, folks. That's all I got for that one.